Hello everyone and welcome back to Study Ed. Today we're covering the Class 9 CBSE Maths Sample Paper for the previous year 23-24, and this is an official sample paper carrying 80 marks. Today we'll be discussing the first 20 MCQ questions and discuss the ways how we're going to solve that. Let's start. First question. Point 0, negative 4 lies in. So 0 is the abscissa, minus 4 is the ordinate, which is going to lie on. Let's draw a Cartesian plane, and we must be knowing our quadrants, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So out of this, where is this point going to lie in? Now, quadrant I, this is x, x negative, y, y negative. So 1 is a positive, positive, 2 is a negative, positive, 3 is a negative, negative, and 4 is a positive, negative. This represents abscissa and ordinate. If we try to correlate the points here, negative 4, ordinate, should be either quadrant 3 or quadrant 4, right? No. Observe abscissa again. It's 0. There's no movement, be it negative or positive. It's 0. So, let's try to consider it over here. This is the origin, 0. So, there's no movement on the x-axis. So, directly the point lies on the negative direction, minus 4 here. There's no movement on x-axis or directly on the y-axis. Meaning, since it lies in the negative direction of y-axis, our option here should be option 1. So, I hope that's understood. Let's move on. Each side of an equilateral triangle is 2x centimeter. If x root 3 is equal to root 48, area of the triangle is. Let's see our given information here. Each side is 2x and x root 3 is root 48. Now, how are we going to find the area of the triangle? First, let us try to find out x over here. So, out of this, x root 3 equal to x root 48. Expand root 48. X root 3 is equal to 3 into 4 into 4. I'm not simplifying this so we can take a square root here. So 4 into 4 directly, it's a square root, 16. X root 3 is equal to, now since this is root 16 times root 13, what is root 16? Nothing but 4. X root 3 is equal to 4 root 3. So transposing this value, we get x is equal to 4. Okay. Now then, after x is equal to 4, we can equate that value into our original value, 2x. Nothing but 2 into 4, 8 centimeters. Area of triangle. Now, equilateral triangle, as we know, the formula is area is equal to root 3 by 4 a square. What is a here? A is the side. So, a is 8. Now, directly transpose those values here. A is equal to 8, which we can input into the sum. So, root 3 by 4 a square. Root 3 upon 4, 8 square. You can, in one of them, right, you can take out root 3 by 4, and 8 square is nothing but 64. So 64 and 4. Cancel out, you get 16. So the answer is nothing but 16 root 3 centimeters square. Now in the options, what do we see? We have C. Option C as 16 root 3. So our final answer is 16 root 3 centimeters square. That gives us option C. We'll mark that and let's proceed. In the given figure, O is the center of the circle. If angle CAB is 40, CBA is 110, value of x is, this is very simple. We just have to use the circular angle property here. O is the center. Constructing a figure, we have here A, B and a straight to C. This is angle X. Under this is angle 40. This entire is angle 110. And with this information, we have to find the value of X. First, let's find the value of C, and then we can use the chord property. As we know, all angles of a triangle are 180 degree. So, 40 plus 110 plus C is equal to 180. Now, in this, we are taking the triangle ABC. Note that. And you have to mention it as well. Now, take this 180 is minus 150 is equal to angle C. So, angle C is equal to 30. Now, as we know, AB is a chord to the circle. And an angle made by the chord at the center is twice the angle made by it on any point in the circumference. So, the angle that this chord makes, AB and BC over here, it's twice the angle made by it on the any point in the circumference, and twice the angle refers to the angle at the center, which is X. So X is nothing but 2 times 30, that is 60 degrees. I'll explain it once again. When there is a chord, the angle made by the chord, okay, the angle at the center is twice the angle of that chord, and that chord is at any point in the circumference. So since this is 30, it's twice of it. So 2 into 30 is 60 degrees, giving us the option D. Let's proceed. In the given figure, ABCD is a rhombus. Find the value of X and Y. Okay, here it's very simple. You just use some transposition properties. I'll construct the figure here. A, B, C, D. This is O, 40, X, Y. Now, diagonals of a rhombus are perpendicular bisector of each other. That is a property. So, this is 90, this is 90, this is 90, this is 90. Using this, we can directly take triangles. See, if we take a part of this, AOB, 40, 90 and X. So that's 180 minus 40 plus 90, 130 is X. X is 50. Now we can do 2 things to find Y over here, but we'll take the simplest one of them, AOD. Again, what do you infer? This angle, since they are perpendicular bisectors, this angle is also 40, this angle is 90, and this is Y. So, Y is 180 minus 130 again, that is 50. So, since we have the final value as X is 50, Y is also 50, we get the option as option D. Clear? Let's proceed. This seems a little tricky at first sight, but it's pretty easy to get it out really quickly. Okay, now you just have to use a little bit of a law over here. 4x or 4 to the power x minus 4 to the power x minus 1 is equal to 24. Then 2x to the power x is equal to, okay, so 4x minus 4 to the power x minus 1 equal to 24. Let's try to break this down in simple clarity. We all know that using the property a to the power m by a to the power n is equal to a to the power m minus n. Similar observed over here. Let's take that 4x. Let's make it 4x by 4 to the power 1. Now here we have directly used the law. In order to cut that out, so that we can proceed with the simplification of 24. See, directly on first side itself, we can see 24 is not a perfect square root, a perfect cube root, or a perfect fourth root, and so goes. So we have to change the value by transposing it. Let's equate this, or let's factorize this. You have 4x common in both of them. Let's take 4x out. What do you get? 1 minus. You're taking this out directly. So you get 1 by 4. 4 power 1 is 4 only. That is 24. So 4 to the power x. 1 is nothing but 4 by 4, and 4 minus 1 is 3. So 3 by 4 is equal to 24. Now it's multiplication. Let's take this over to the other side. 4x is equal to, reciprocal it, 4 by 3. So 4x is equal to 96 by 3. That is nothing but 4 to the power x is equal to 32. Now using this information, we can simplify the previously given sum. Now our final output out of the first simplification is that 4x is equal to 32. Now 4 to the power x is 32. We can simplify this in a way that 2 square and x is equal to 32. 4 is 2 square. So 2 to the power 2x is equal to 32. Now we can equate 32 as with a base of 2. 2 to the power 2x is equal to 2 to the power 5. 2 to the power 5 is 32. So equation of bases, 2x is equal to 5, x is equal to 5 by 2. This is our value now for x. With this we can solve the entirety of the sum, 2x to the power x. Now 2x is nothing but 2 into 5 by 2, the whole to the power 5 by 2. We can cancel this out. 5 to the power 5 upon 2. So out of this, we can directly make it root of 5. You make this over here, as in you can express it as 5 to the power 5 times 1 by 2. This, then you can make it, since you have 5 terms, it's nothing but 5 times 5 times 5 times 5 times 5. Bar. You only have 1 5 left. So you're taking out both the 5s, since you can directly square root that. And then out of that root equation, what do you get over here? 5 times 5 root of 5. 25 root 5. This is our final answer that we have just concluded through this. And out of that, we can observe option B is the correct. So option B. This is a straightforward sum. Congruence theorem. B is equal to C. AD is perpendicular of BC. Rule by which ABD is congruent to ADC. B is equal to C, or ABD is equal to ACD, sorry. Then BDA is equal to CDA. How are we saying this? 90-90, equal, right angles are equal, and both of them, it's common. AD is a common side. AD is equal to AD. One angle, two angle, one side. Combine all of them. AAS theorem, angle side theorem. So using this congruence property, we can say AAS criteria fulfills this. So that's 6D. Simple. How many lines pass through one point? This is also very straightforward. Look, 1 point can be the solution of many equations. 1 line, 2 line, 3 line, 4 line, 5 line, 6 line. I can go infinitely. How much ever lines pass through this? See, two distinct points one can pass, but through one point n number of lines can pass. Infinite. So out of that we observe 1, 2, 3 and many. Clearly 7D is the correct answer. Degree of a zero polynomial is. Now, a form of a polynomial is an xn. N is supposed to be a natural number. So when a zero polynomial, an is 0. Now, the biggest value for a non-zero an is infinite or somewhat around negative infinity. All integers are bigger than negative infinity. See, over here you're directly taking the polynomial as 0 because it cannot be further expressed into anything else. So you can't have a specified value or a degree for a zero polynomial. Hence, it has to be not defined. A constant polynomial can have a degree, but not a zero polynomial. Hope that's understood. Then let's continue. So 8 is not defined. Simplest rationalization factor, 2 root 2 minus root 3. We all know, very simple, a square minus b square is equal to a minus b into a plus b. Same, a minus b is over here, a plus b is 2 root 2 plus root 3. This is our final value. That gives us b as the correct option. Diagonals AC and BD of a parallelogram ABCD intersect each other at point 2. Construction. See, construction is absolutely not necessary, but in sums like this where they have not given a figure, it is highly recommended because without it you could fall behind. A, B, C and D. Diagonals AC and diagonal BD intersect each other at point O. DAC 32 and then AOB 70. What is the value of DBC? Now we know that DAC is equal to directly ACB. Alternate angles. This angle ACB is equal to this. Assume it as such. Alternate interior angles. So ACB is equal to 32. Now AOB and BOC. See this over here. And you take these two angles. AOB plus BOC is equal to 180. Now, as we know, already given information, directly we can say COB is or BOC is equal to 110 because AOB is 70. Now, you take the entire triangle BOC again over here, this triangle. We observe that this angle BOC is 110. OCB, this angle is 32. And we're told to find the value of CBO over here. CBO is equal to 38. By subtracting this, we get CBO is 38 degrees. Now, our given value is to find the angle DBC. This one. So, directly write this angle and this angle, both of them are the same. So, DBC is nothing but 38 itself. That gives us 10B. if x to the power minus 2 is 64, x to the power 1 by 3 plus x to the power 0 is equal to what? Exponential simplification, also very simple. So let's take the first one. X to the power minus 2 is equal to 64. This time let's take equal powers. So we can say 1 by x square is equal to 8 square. Take this whole 1 by x, the whole square is equal to 8 square. Hence, we can say that 1 by x is 8 and x is equal to 1 upon 8. This information is somewhat enough for us to proceed because we see we have a cube root and 8 is also a positive cube. So 1 by 8, 1 by 3 to the power 1 by 3 plus 1 by 8 to the power 0. This is a cube root. We know that 8 cube root or 2 cube is equal to 8. So cube root of 8 is 2. So this gives us 1 by 2. And anything to the power 0 is 1. Further simplify that. 2 plus 1 by 2. That is equal to 3 upon 2. So we get the final value of this equation as 3 by 2. That is 11c. The linear equation 2x minus 5y is equal to 7 has how many solutions? This is also a straight up given answer. There is no value of x and y. Vice versa too. For any value of x, you have a corresponding value of y. For any value of y, you have corresponding value of x. Given that we have no values here, it directly has infinitely many solutions. In the adjoining figure, if AB is parallel to DE, then the measure of ACD is equal to. So, if these are parallel, right, let us directly take over here. Now, we can construct this figure and extend it further. This is A, B, C, D, and E. Okay, now let's extend this figure over here and this figure too. We get 110, 150. According to parallel angles, we get that the angle over here, since we have extended this and extended this, 110 directly alternate angles 110, meaning this angle on the interior is 180 minus 110, that is 70. Now for this angle, linear pair 150 plus CD, and let's assume this as O, CDO is 180, so this angle over here is 30. And then taking this triangle, this angle over here, what is the value of this? 180 minus 100, which is equal to 80 degrees. Now remember, 80 is not the final answer, we just found out that. Still, we have to find out the angle here, ACD. So we know ACD plus DCO is a linear pair. So angle ACD plus 80 is equal to 180, and ACD is nothing but 180 minus 80, that is 100 degrees. So the answer here is 13B, which is 100 degrees. The value of 32 to the power 1 by 5 plus minus 7 to the power 0 plus 64 to the power 1 by 2. It's pretty straightforward, you know. 5, 32 plus directly 1 since it's power 0, and then 1 by 2 fractional means square root 64. So we know 2 to the power 5 is 32 plus 1 plus 8 square. Cancel the roots. 2 plus 1 plus 8, which is 11. Hence our final answer here is 11, giving us C. In the given figures, if chords A, B and CD of the circle intersect each other at right angles, then x plus y is equal to what? This is also pretty simple. See, angles, they are lying on the same arc. So angle Y is equal to angle ACP. We can say that based on this arc. Then let's take angle APC. It is equal to 180 minus 90 since the other angle is 90. Now, if we take triangle APC, then we see that angles ACP plus X plus APC should be 180. We know that ACP directly is Y. We just show that here. So X plus Y is equal to 180 minus 90. We found out that APC itself is 90 over here. So X plus Y is equal to 90. Simple. 15C. Abscissa of all points on the x-axis. Again, this is very simple. This is an x-axis and this is y-axis. Y negative, x negative. Now, abscissa means the x-coordinate. For a point to lie on the x-axis, that is, if it wants to stay in the x-axis itself, it should not move upward or downward. Meaning, it should not move up the y-axis, move down the y-axis. That means there should be zero movement on the y-axis. So for a point to lie on the x-axis, it can have any number, let's say n. The abscissa can be any number. The ordinate, it needs to be 0 so that it lies on the x-axis. Meaning n can be any number. Any abscissa, ordinate should be 0 for a x-axis. So any number directly. Express y in terms of x in the equation 5x minus 2y is 7. 5x minus 2y is 7. Let us transpose x to the other side. Minus 2y is equal to 7 minus 5x. Now since it's a negative, let's take it there. 2y is equal to a negative 5 minus x. So positive, it becomes over here and this becomes negative. So that's 5x minus 7. Y is equal to 5x minus 7 upon 2. Taking the 2 that side. So that gives us option A, 5x minus 7 divided by 2. If P of x is 5x minus 4x square plus 3, then P of minus 1 is. So let's reorder this. Minus 4x square plus 5x plus 3. X value here we replace it with minus 1. So minus 4 minus 1 square plus 5 to the power 5 into minus 1 plus 3. Minus 4 and minus 1 square is directly 1 plus minus 5 plus 3. So that's minus 4 minus 5 plus 3. That's minus 9 plus 3 is nothing but minus 6. So we take out over here 18b minus 6. 19th question. ABCD is a square. AC and BD intersect at O. Measure of AOB is 90 degrees. And reason diagonals bisect each other right angles. Very, very straightforward. It is directly correct. In a square, any square. I'm not taking points here. Any square, you can say diagonals intersect at some point. These angles are all 90. It is the property of it. So both A and R are true and R is the correct explanation of A. Since they bisect each other at right angles, the measure of AOB is 90. And for the final question, guys, assertion root 3 is an irrational number. Square root of a positive integer which is not a perfect square is an irrational number. This is also correct because we have root 3 over here. 3 is not a perfect square. The perfect squares are 1, 4, 9, 16 and so on. 3 is not a perfect square. So the square root of any positive integer which is not a perfect square is always an irrational number. This also gives us the proof that reason is the correct explanation of the assertion and both of them are correct. So 20 is A. That's it for the MCQ for this sample paper, guys. Thank you so much for watching. Please make sure to like and subscribe, and I'll see you guys in the next video where we're continuing with the subjective part of this sample paper. Thank you.